Okay, so here's some more examples with solving logarithmic equations. So we're still going to try to find when does log equal log or when does log equal a number. Based on that, if log equals log, we'll set whatever we're taking the log of equivalent to each other. If it's log equals a number, we'll change to exponential form. Remember to use your properties first. So on the first example, or example 4, if I'm continuing from the last video, first thing I notice is that every single property has a type of log, the natural logarithm to be specific, attached to it. Therefore, I am going to anticipate that this is going to be an example where I do log equals log. So I want to try to make sure I have one log on each side. So looking at the right side, I can combine these logarithms with division since I have subtraction here. So I'm going to go ahead and say that I have ln of x plus 5 equals ln of x minus 1 over x plus 1. Now that I have log equals log, I'm going to go ahead and say that must mean that x plus 5 has to equal x minus 1 over x plus 1. Rational equation, I cross multiply and I get x plus 5 times x plus 1 equals x minus 1. I FOIL. I can FOIL fairly quickly, so if you don't understand where I got my FOIL from, please let me know. But I will FOIL and get x squared, and then I will have plus 1x plus 5x, so plus 6x. 5 times 1 is plus, oops, I forgot my x, plus 5 equals x minus 1. I see my equation is quadratic, so I'm going to set it equal to 0 by subtracting x and adding 1. And I'm going to bring it up here, and I'm going to have x squared. 6x minus x is plus 5x. 5 plus 1 is plus 6 equals 0. I see I can factor this to be x plus 2 times x plus 3 equals 0, which means x either has to be negative 2 or x has to be negative 3. Well, if x is negative 2, I am going to have a positive number here, so I'm good. I'm going to have a negative number here. I cannot take log of anything less than or equal to 0. I have to be greater than 0. So I see that that is not going to be a solution. If I check negative 3, I see I'm going to run into the same situation here, so that won't either. So I'm going to go ahead and say no solution. Looking at the next example, I'm going to do the same thing. I first determine is it log equals log or log equals a number. So I see I have a log with this expression or this term. This term has a log. This term has a log as well because the 3 is attached to the log. So I'm going to try to make it so it's log equals log by getting one log on each side. Well, I can combine the left side by using division based off of my logarithmic properties. The right side, I can bring the 3 to be an exponent, giving me 4 cubed. Well, that means x over x minus 1 must be equal to 4 cubed. 4 times 4 is 16, times 4 more is 64. I cross multiply, giving me x equals 64 times x minus 64 times 1. Combining like terms, I get negative 63x equals negative 64. I'm going to divide both sides by negative 63. I know a negative divided by a negative is just a positive. And then I check to make sure this doesn't give me a 0 or a negative number anywhere. So 64 over 3 is going to be just a little bit more than 1. So it's positive here, I'm good. 64 over 3 minus 1 is going to be a positive number. I don't know what it is, but it's not 0 and it's not negative, so it's okay. 4 is always going to be 4, so it looks like my solution worked. Looking at one additional example, I see this is a situation where I have this term having a log, this term having a log, but this term does not have a log. It is simply a number. So I'm going to go ahead and I'm going to try to solve this. So I don't think this is the problem I wanted. I actually, well, that's fine. I'll work this one. So I'm going to go ahead, like I said, I'm going to try to get to log equals a number. So I'm going to go ahead and add this to both sides to start. According to my properties, when I add logarithms, I multiply. So I'll have ln of x times x plus 2 equals 1. I'll now change to exponential form. I know ln is base e, so I'm going to have e to the 1 equals x squared plus 2x if I go ahead and distribute that x in. I can see this is quadratic, so I'm going to set it equal to 0. E to the 1 is just e. From here, I'm not going to be able to factor. I'm going to have to go ahead and use the quadratic equation and say x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Doing that, I get negative 2 plus or minus the square root of about negative 6.873 all over 2. Well, I know this is going to be an imaginary number, so I don't have to worry about it. From here, I can go ahead and say no solution. I think the problem I had meant to have in looking at my notes is I had meant to type log of x equals negative log of x plus 2 plus 1. If I run through that quickly, the first step would have been the same to move the negative log of x plus 2 over. The second step would have been the same to change to multiply. Now I would have changed to exponential form, saying 10 to the 1 equals x squared plus 2x. So then I could have subtracted 10 from each side. Actually, that wasn't what I wanted to do either. I'm all over the place. I'm going to go ahead and just stop this problem. I'm not going to look at that. The base that I had wanted to do was base 3. So I think what I'll do is I'll save that for an in-class example one day.